A 10 millimeter diameter electrical conductor is covered by an insulation of 2 millimeter thickness. The conductivity of the insulation is 0.08 watt per meter Kelvin and the convection coefficient at the insulation surface is 10 watt per meter square Kelvin. Addition of further insulation of the same material will: option A, increase heat loss continuously, B, decrease heat loss continuously, option C, increase heat loss to a maximum and then decrease heat loss, and option D, decrease heat loss to a minimum and then increase heat loss. So in the problem we are given a 10 millimeter diameter electric conductor, let's write here, and it is covered with 2 millimeter thickness of insulation. Okay, so the outer radius, let's first draw the wire here. Now let's say this is the given conductor. So the inner radius, this yellow cylinder, so let's say this is R1, which in the problem is 5 millimeter, and above this there is an insulation of 2 millimeter. So the outer radius, let's say R2, will be equal to 5 plus 2, that is 7 millimeter. Okay, now there is something called critical thickness, and it can be defined as the thickness up to which the heat flow increases and after which the heat flow decreases. Also the critical radius, let's say this red cylinder is the critical radius, let's write RC for this, and for cylinders it is given by K upon H. Okay, so this will be, in the problem the value of K is 0.08 divided by H, which is 10, so this will be equal to 8 millimeter. Now the insulation radius at which resistance to heat flow is minimum and consequently heat flow rate is maximum is called critical radius, RC. And in this case we can see RC is 8 mm, so obviously this line will have to shift above this white line. So let's try it again. So this will be the critical radius of insulation, okay, from this point to this point, that is 8 millimeter. Now the rate of heat transfer from cylinder increases with addition of insulation, that means for R2 lesser than RC, and reaches to a maximum when R2 is equal to RC and starts to decrease for R2 when this R2 is greater than RC, that is critical radius of insulation. Thus insulating the pipe may increase the rate of heat transfer from the pipe instead of decreasing it when R2 is lesser than the critical radius. Now according to this problem we have already calculated the R2, that is 7 millimeter. So the rate of heat transfer will increase up to 7 millimeter and then it will decrease. Let's see in a diagram. Therefore at critical radius the heat is maximum. Okay, so from here we can say that option C is the correct choice. Increase heat loss due to maximum and then decrease heat loss. For more information you can refer to the NPTEL course lecture number 16, critical insulation thickness, on conduction and convection heat transfer by Professor S.K. Sohn of the Department of Mechanical Engineering at IIT Kharagpur.